Hello friends, let's discuss the limitations that we have so far in our design of a matching engine using a one-dimensional data structure of linked list and priority queue. Now the first limitation is orders with the same price are placed at different levels in the data structure. So what it means is we see that the top three orders here, these are all sell orders. And we see that there are two prices like 20.2, 20.30. These are the same price, but what we have done, because we are using one-dimensional data structure, we have placed it at different levels. So this order, right, order ID 1, this is having that because this was arrived earlier. That's why this order has higher priority than the one which is order ID 3 at top of it, which arrived at 905. So this order is having higher priority than the above one. That's why it is placed near to the best here to the below of it. Similarly, the price is like less. Of course, we know that for the sell orders, the lower the price, the higher the priority. So this is giving the highest order. But for the same price, because of the different timings, we are having two different levels for same order ID 1 and 3. If I again go to the buy orders, so we can see the same thing that for 20.15. Now for buy orders, as we know, the higher the bid price, the better the priority. So that's why 20.20 is having is our bid right now in this order book. But for the same price of 20.15, the same bid price of 20.15, we see that this is having higher priority because it arrived at 906, and that's why it has got higher priority than the order ID 6 of 909, because earlier the order arrived, it has got a better time priority. Now, in the real world scenario, right, where we have in the exchanges where we have got hundreds and thousands of orders at the same price, this is not an efficient solution, right? Because suppose, if I want to know, just for my algorithm, if I'm running an algorithm for matching orders, in that case, if I want to know that how many orders are there at level 2, for example, I want to know that how many open orders are there at this price 20.15. Now there could be hundreds and thousands of orders, I can say, and each order would be having some random quantities, like some different quantities. If I want to know the total volume of open orders present at this price in the one-dimensional data structure, I have to go through the whole list, right? And then it would be O of n. And similarly, if there are like more sophisticated algorithms, in that case, we want to know that what is the best price available at after the best price, what is the next best level of price, or what is the next top 3 level of price, and what is the total volume at that price. In those scenarios, it would be very difficult to run it efficiently using our one-dimensional data structure. And the second limitation of using one data structure is the performance. As we have seen that if we are using linked list, in that case, only the matching part is good, but for all the other things, priority queue is better. So if we are using one-dimensional structure, either of them, we are going to suffer the performance, especially for the matching part, right? Here we can see that priority queue is all good except for the matching part. But for a matching engine, matching is the most important stuff. And here we can see that only the linked list is having slightly better performance than priority queue. Not slightly, but it's like whole n of log n, this n is quite better performance. So we cannot rely on just priority queue for building our complete order engine, and we cannot even rely on linked list for the whole design, right? Because for addition and for amendment, it's very poor performance. So these are the two limitations. And in the real world exchanges, what I have from my experience, what I've seen is that orders are grouped by price levels. So what it means is that, let me show it in a diagram. So this is what I mean by a two-dimensional order book. So the top one is our one-dimensional order book, in which we are maintaining the different price levels for the same price but for a different time. So if I transform this whole thing into a 2D order book, this is how it will look. Now let me go through the details. So right now we have got different price levels, right? Like 20.30 here, it is matched to 20.3, 20.25. So we only have got one price level for each price, not spread across. And for each price level, whatever the orders are there, it would be stored as a doubly linked list. For example, at 20.3, we can see that this order ID 1 arrived at 901, right? So it is at the top of this linked list, at the head of the linked list, because it has got higher priority. And the subsequent orders at the same price of 20.3, which is here 905, it is going as a next node, 905. And now if we keep on getting some new orders at the same price, we will keep on appending to the tail of this linked list. So in essence, what we are trying to say is that at the same price level, it would be only like one price level, and all the other orders at the same price but having different time priorities, the head having the best time priority would be placed at the head, and the subsequent orders with the next time priority, whichever arrive later than that, it would be so appended to the tail of it. Same goes with the buy order. We can see that for buy order, we have got the best price at 20.20. That's why we have got only one price level here. And then we append at the head of it the best time priority, which is only one, which is 908. So it is here. Similarly, for 20.15, we can see that there are like two prices in our 1D order book. But for 2D order book, it would be here, only like one price level available. But at the head, it would be the best time priority, which is 906 here. It will be placed at the head of this linked list. And the order 2 at 909, that would be appended at the tail of it. And as soon as we get the same different orders later on at the same price of 20.15, it will be always appended to the tail of it. So this is how, just think about it, right? I mean, if the real exchanges, we are going to have hundreds and thousands of orders at the same price, all would be appended to the tail. And it's very easy to calculate now that what is the best order available at this price. It's always at the head, right? And we can also do some like bucketing, where we can calculate what is the total quantity, total volume at this price. We can just add all the orders of this linked list and store it in our in some state where we can store all the quantity, and also we can do some other algorithms. Like, for example, we can also say that it's very easy from here to navigate that what is the next best price after the best ask price, right? We can simply go to the linearly up of this price levels. So all these algorithms make it much easy by this 2D design. So this will be our final design. We will be using our 2D order book design, as we just discussed. And for maintaining this price level, right, we are going to use PriorityQueue just for maintaining this price priority. And the corresponding ask, you can see a linked list here, right? For that, we are going to use a hash map to store at this price, and the value would be a double ordered linked list, doubly linked list for this whole chain of orders at the same price. So having this design price, it would be used for only as a PriorityQueue. Once the best price is found, we can use a hash map, right? We are creating a hash map with the key as this price and the value as a complete linked list, doubly linked list of having all these orders in the chain. And we can see that when we are trying to match, right, we always know that at the head is the best time priority available at that price. So it would be much easier to just use the linked list data structure, as we have seen that getting the head of the linked list is O1. That's why, and for the PriorityQueue, we also know that there are a lot of good algorithms. Like, for example, if you want to add it, it will be log n only, and if you want to sort it, it would be again log n. So all this would be taken care by the PriorityQueue. So by using the 2D approach, now what we are doing is that we are taking advantages of both the data structures, PriorityQueue and linked list, and then this design is much robust and scalable, and we can do a lot of algorithms, that what is the price level at that price level, what is the total amount of order quantity available, what is the total volume available, and much more. So we'll see the actual Java implementation code in the next videos.